Hello dear children, in today's class we will be discussing the graphs in a kinematics. Dear children, this topic is a very important not only for board examination but also for competitive examinations such as NEET and mains. Dear children, when it comes to the graph, many times, many students they have a confusion. What kind of graphs we have to study, how the graph is going to be. Some students even have seen that they'll be by-hearting the graphs. And one more important thing is that, they'll be thinking, is the graph with a straight line or a parabolic or a circle or a hyperbola? Dear children, we should not by-heart the shape of the graphs, first point. Then you may get one doubt. So then how we should do the shape of the graph between the two quantities? Yes children, so in today's class, I am going to give you the full clarity about the graphs. So before going to discuss the graphs related to kinematics, let us go through some important points. Let us recall, let us understand some important points so that we get a complete grip on the graphs related to the kinematics. Okay na? So let us see that what are those important points so that we get a command. Yes. So look at here some key points. The first one. So graph is drawn between two variables. You make a doubt, sir. Is this point also important? Yes, of course. It's a basic point, right? So we draw the graph between two physical quantities. I can say two variables. Example x and y. So when it comes to the kinematics, in the place of x and y, we may draw a graph between displacement and time, or a velocity and a time, acceleration and time, and sometimes displacement and velocity graph also we have. Means st graph, vt graph, at graph, and even sv graph also we have. Means we draw the graphs, we study the graphs between st, vt, at, and sv. Is that clear? Fine. And here, yes. And as I already told you beginning only, then how to know the shape of the graph, how to decide. Children, who are we to decide? It is not that. See, as we are discussing about the relation between the two, we are trying to make a graph between the two variables, definitely they might be related. Means there will be a certain relationship between two physical quantities. So with that we get one equation, right? Means we have one special equation which gives a relation between two physical quantities, that is two variables. Hence, the equation between that particular two graphs will decide the shape of the graph. It is not we. So what is the equation which we get? That equation will decide the shape of the graph between the two physical quantities. Okay, fine. And here that equation, see, that equation might be linear equation or a quadratic equation. If the equation between the two physical quantities is linear, then we get a straight line. We get a straight line. Okay. If the equation between the two physical quantities is a quadratic, if we get a quadratic equation, then we get a parabola. So the shape of the graph depends on the equation between the two physical quantities. And here you may get one doubt, sir. Sometimes we have seen that graph will be passing through the origin. In some other cases, it won't pass through the origin. Then how to decide? Okay, linear, okay, straight line only. But how to know that whether the straight line passes through the origin or not? It's a parabola, okay. Whether that parabola starts from the origin or not, how to decide? Yes, for that also we have one more important point to study. So children, so as I told you that particular graph, it may pass through origin or may not pass through the origin. But how to decide? Yes, let me tell you. For suppose children, okay, let me take here space. Let us take one equation. We have two equations. Y is equal to, for example, mx plus c we have, and y is equal to mx. These two are the linear equations only, which means what? We get a straight line only. But in these two equations, let us substitute y is equal to mx. Let us substitute x is equal to 0. In both cases you substitute. If you substitute x is equal to 0 here, then we get y is equal to 0. But here if you substitute x is equal to 0, you get y is equal to c. Means there will be some y-intercept. So whenever you substitute here x is equal to 0, if you are getting y is equal to 0, Yes, that straight line passes through the origin. If you substitute x is equal to 0, you are getting some value for y, that is there will be some y intercept, which means what? That straight line doesn't pass through the origin. Even same thing happens with the parabola also. You have to check in that equation, if you substitute x value, x is equal to 0, if y is equal to 0, then that parabola starts from the origin. If you substitute x is equal to 0, if you are not getting y is equal to 0, then that won't start from the origin. Okay, so for this, yes, we get equation like this. This is what actually you get. But whereas for this, we get, this means there will be some y intercept. Are you able to see my board? Yes. So this is how actually we decide whether a straight line or a parabola. If it is a straight line parabola also, how to know whether it passes through the origin or not. So this is the point where we have to focus. Is the point clear? Yes. Now two more important points. Okay. Now let us come to this one. So if z is equal to dy by dx, then that z is obtained by the slope of yx graph. Children, if you can draw any graph between any two variables, from that graph we also can obtain a third physical quantity. So it depends whether are we calculating the slope of that graph or area under the graph. For suppose, let us take this only as z is equal to dy by dx. For suppose this is what actually we got a graph. This is x, this is y. Okay, we got a one straight line passing through the origin. Let us say that. And for this, let us calculate the slope, children. Yes, let us take here for this x1 value, here corresponding y1 this will be, and for this x2 value this will be a corresponding y2. Then this will give you change in y value, this will give you change in x value. So by finding this slope of the graph, we can obtain the z value. Let me give you example. For suppose, let us take a time and a displacement. Let us take, here is a graph, children. So here this slope of this graph ds by dt, this give you velocity. Means by finding the slope of st graph, we can find the velocity. Same thing happens for suppose, let us take here velocity time graph, children. So the slope of velocity time graph gives acceleration. So this is how, means by finding the slope of a given graph, we also can find a particular physical quantity. Is the point clear? Yes. And the last point here, so if dp, see already here I have used z, here I am using p. Okay, now otherwise don't think, sir, what is this p called here? Some physical quantity. So which means what here, as a dp is equal to, means this is a change in p value. So how to calculate change in p value means by multiplying a y and a dx, which means what, this y into dx is nothing but the area of that particular graph, children. Let me give you one example. For suppose, let us take a velocity time graph only. So for suppose here time and here is a velocity. I got a graph like this. Okay. So this area under the velocity time graph gives a displacement. Means here is a velocity and this is a change in time here. So here v into dt gives you the change in displacement. If we can take an acceleration time graph, we get, here is a displacement, we get a displacement. If you take a acceleration time graph, or suppose here t and is the acceleration. For suppose here you got something like this graph. So this area under this graph gives you the change in velocity, that is a into dt gives you the dv value. Is the point clear? So by finding the slope and by finding the area under that particular graph, we also can obtain other physical quantities. Now let us try to what we can, okay, have you copied this, children? These points are very important. Okay, copy this. Okay, fine. And once again, let us see ST and VT and AT graphs, slopes and area under that. You know, already you have learned, you had learned in a class, but let us see once again. For example, children, if it is a ST graph, means from this ST graph, okay, so slope of ST graphs gives you velocity. Here area under the displacement time graph, we don't get any physical quantity. Okay, fine. When it comes to the velocity time graph, for a velocity time graph, the slope under velocity graph gives you acceleration, whereas the area under the velocity time graph gives displacement. Okay, so here we can calculate acceleration and as well as displacement from velocity time graph, whereas the velocity we can calculate from the slope of the displacement time graph. The third one is acceleration time graph. So here, so the area under acceleration time graph gives change in velocity, whereas the slope of acceleration time graph gives jerk. Generally we don't study about this in a class 11th or 12th standard, only in higher studies, in a PG level only. It means the rate of change of acceleration is also called as jerk, but we in our syllabus nowhere it is given, so that we are not going to discuss about the jerk even. So these are the basic points we should know to understand the graphs in a better manner. And the children, for a better understanding about ST graph, VT graph and AT graph, one-dimensional motion is classified into 4 categories. This is a very important, children, here. Generally we study as ST graphs, AT graphs and VT graphs, right? But we are going to study all these 3 kind of graphs. I mean, we are going to classify these 3 types of graphs into 4 categories, so that our discussion will become very easy and we don't have any kind of confusion. And the first category is a uniform motion. Second one is uniformly accelerated motion. Third one is uniformly retarded motion. Fourth one is uniformly retarded and uniformly accelerated in an opposite direction. So in these 4 what we can say types, how displacement time graph, how velocity time graph, how acceleration time graph will be, means what kind of shapes are we going to get ST, VT, AT graph under these 4 types we will see. So first we will discuss the uniform motion. Children, hope it is copied. Fine. Children, you just think, what do you mean by uniform motion? When you can say that body has a uniform motion. So here, first category is uniform motion. First category is what, children? Uniform motion. So children, when a body is covering equal displacements in equal interval of timings, then we can say that body has a uniform motion. Means as a body is covering equal displacements and equal interval of timings, can we say that velocity is a constant? Yes. So that is the first key point to us. Velocity is constant. Velocity is constant. As velocity is constant, children, acceleration will be what? Acceleration is nothing but the change in velocity by time. As velocity is constant, change in velocity by 0, which means what here? Acceleration is 0. Children, as I told you that in every type of motion, in every classification, first we should see what kind of equation we are going to get. So in this, velocity is a constant, that's it. Here acceleration is 0. When a body is moving with a uniform motion, whenever body has a uniform motion, we can write displacement is equal to, or else we can write it simply velocity is equal to displacement by time, or we can write displacement is equal to velocity into time. So this is a displacement time relation, children. Or we also can write like this, right? Displacement is equal to S naught plus VT. You may get one doubt, sir, how can you write a S naught? Children, just when we started studying the motion, before body might be having some displacement, right? It's not like a starting from the rest. See, when we are studying the motion of a body, 2 possibilities are there. Body starts from the rest. When body starts from the rest, displacement will be 0, right? So this is S is equal to VT, means you put here T is equal to 0. When T is equal to 0, displacement will be 0, which means what? It is starting from rest. Whereas here you put a t is equal to 0, then here you get a, means as a t is equal to 0 children, s is equal to s naught, which means what? Body has some acceleration. Now let us see what kind of graphs are we going to get. It's very easy. Okay, first children, so look at here. So first we study the displacement time graphs first. So we are going to study in this, means under uniform motion. First we are seeing displacement time graph. Children, if you can see displacement time graph, s is equal to vt or s is equal to s naught plus vt. So these are linear equations, like a y is equal to mx, y is equal to mx plus c. So we are going to get a straight line, means under uniform motion displacement time graphs are straight lines, no doubt about it. And in this case, as a time is equal to 0 means displacement is 0, which means what? Here again two possibilities are there. Here it is starting from the origin, means this is the time and here displacement. So as s is equal to vt, it's a linear equation starting from the origin. That's it. Okay, fine. And here second one, this one only, means there is some y-intercept. So which means what? Here time and here is a displacement. So this is what actually y-intercept s naught value. So this is how actually we get a displacement time graph for what children? For uniform motion. Fine. Now let us see how Vt graph is going to be. It's very clear that V is a constant, right? So here Vt graph is going to be time and here is a velocity. So we get a straight line parallel to the time axis. That's it. Children, try to understand. Just based on that particular equation we are getting the particular shapes. Okay, fine. And here third one here, what is that? Acceleration time graph. Children, in acceleration time graph, if you can see, this is a time and this is the acceleration. So acceleration is 0, right? Which means what? Here we get a straight line only, but coincides with the time axis. That's it. This is a uniform motion. Just copy this. Now we study the uniformly accelerated motion. Children, it's very simple. Uniformly accelerated motion means what? Acceleration is uniform. When is the acceleration uniform, children? The change in velocity must be constant. That is nothing but the acceleration. So which means what? Here one important point to be noted here. So here acceleration is a constant and it is positive. Acceleration is a constant and it is positive. It happens velocity and acceleration both are in the same direction. Velocity and acceleration both are in the same direction. Then only what happens? Acceleration is a constant and it is a positive. I am talking about this actually. It is a positive. Okay. So acceleration is a constant, the first equation for acceleration. Now let us talk about the velocity. So under this uniformly accelerated motion, how the equation of motion is going to be for a velocity? Children, we know that here v is equal to, we have u plus at velocity. V is equal to u plus at. This is very important to be noted. Or can also write here v is equal to at. Yes. What is the difference between these two equations? Just you think. What is the difference between these two equations? Means here as you substitute u is equal to 0, then we will get a v is equal to at. Which means what here? Here this equation we obtain when a body starts from rest. Okay, but where means here there is no initial velocity. Here some initial velocity is there, so body is not starting from the rest. Body is not starting, means in the, see, these both are linear equations only. Which means what? So Vt graph is going to be straight line, no doubt about it. Okay, fine. And here the third one is let us talk st. So for st, for a displacement time, how the equation is going to be? Equation is going to be s is equal to ut plus half at square, or if it has initially some displacement, then we get s is equal to s naught plus ut plus half at square. So these are the equations. These are the equations for acceleration, velocity and displacement. Now let us think how the graphs are going to be. Children, this is what actually we are going to follow, right? First we are going to study the equation. Based on the equation, we will come to know that whether we are going to get a straight line or a, what we can say, parabola. And after that we will think whether it is starting from the origin or not. So when it comes to the first acceleration graph, let us see. Yes, the acceleration is a constant, so no need to think much about it. So how the acceleration time graph is going to be, children? So here this is time and this is the acceleration. So acceleration is a constant and positive, that's what we get on a positive x-axis. Try to understand, difference is there. Okay, fine. Now when it comes to the velocity time graphs, let us study the velocity time graph equation. So these are linear equations, right? Then obviously we are going to get a straight line. We are going to get a straight line, so no doubt about it. Okay, so and here let us say this is A, again it is B. Okay, now first let us think about the for B relation, that is V is equal to AT. So in this V is equal to AT, if you can see, if you substitute T is equal to 0, yes, velocity is equal to 0, which means what here? This particular straight line starts from the origin. Hence, we get, this is time and here is a velocity. We get a, this is how we get. Okay, okay. When it comes to the A, that is V is equal to U plus AT. So when you substitute T is equal to 0, children, here V can't be 0 and V is equal to U, means there will be some y-intercept, means what? It is not starting from the origin. So we get, this is time graph, this is velocity. So we get straight line, but like this. So this will give you some y-intercept U, y-intercept. So this is acceleration time graph, velocity time graphs. Now third one, let us see about the displacement time graph. Children, just study the displacement, the relation between the equation for a displacement time graph. So these are quadratic equations, right? Quadratic equations, children. Whenever we get a quadratic equation for a two physical quantities, we are going to get a parabola. So in a kinematics, children, mostly for a displacement time graphs, all equations are going to be a parabolic. Is it clear? Fine. Now here also, okay, parabola we are going to get for a displacement time graph relation. But how to decide whether that parabola is starting from the origin or not? Very simple. Put the time is equal to 0. If you get a displacement 0, start from the origin. Put the time is equal to 0. If a displacement is not 0, then it won't start from the origin. Very simple. So look at here. So let us say for a displacement time graph only, it is the first equation and here is the second equation. So for displacement time graph, if you can see this first, let us say it's A, B, sorry, so that we don't have any confusion, B let us say. So for A, in A, if T is equal to 0, you put, yes, S is equal to 0. Hence that parabola starts from the origin, no doubt about it. So we are going to get time is the displacement. So we are going to get like this. Okay, na? So at any point, this will give you what actually, if you can draw a tangent, you get a slope. You will get a slope. So the slope of displacement time graph at that point will give you the velocity. And if the slope is increasing, we get a positive slope, which means what? Velocity is a positive. Okay, fine. Now let us see this B relation. So in a B relation, children, if you put T is equal to 0, then displacement has some value. Here displacement is 0. That's what it is starting from the origin. Here displacement has some value. So that particular parabola won't start from the origin. Then we get a graph like this. So time and here is a displacement. So we get this how. So there is some displacement value. So children, I repeat once, whether it is starting from the origin or not, it is not in our hand. We are not the one to decide. So purely it is decided by the equation between the two particular physical quantities. So this is second type of classification, uniformly accelerated motion. Now we discuss the third type, uniformly retarded motion. Have you copied this? Just copy this. We go to the third classification. Okay, fine. uniformly retarded motion. Children, retardation means what? When it happens when acceleration and velocity both are in opposite direction. For suppose, just I am telling you, for suppose the body is moving in this direction but acceleration opposite direction. Is it possible? Yes. Force is acting in opposite direction, right? It is a retarded. It is called retarding motion. So, in which acceleration and velocity both are in opposite direction. Of course, velocity is positive only, but keeps on decreasing. And finally what happens when time comes? Yes, velocity becomes 0, right? Yes, it is possible. It is possible. Means as it is a retardation, what can you say about the acceleration? It is a negative, but a uniform. Uniform means the first point. Okay. So first one. So acceleration is constant only. Acceleration is constant but negative. Acceleration is constant but negative. Then how are we going to get acceleration time graph? Time is the acceleration. So do we get in a positive side? No. So here negative side we are going to get a negative acceleration. But it is a constant. This is how acceleration time graph is going to be. That's it, over. Okay, fine. And here second one, V is equal to U plus AT. But here A is a negative, right? So we can write V is equal to U minus AT. And if you can study here, you may get a one doubt. Okay, it is a linear equation, no doubt. It is a linear equation. So we get a straight line. We get a straight line. And here you may get a one doubt. Sir, is that straight line passing through the origin or not? Let us see how. Let us put t is equal to 0 in this equation. T is equal to 0. Then V can't be 0, right? So under uniformly retarded motion, velocity time graph can never pass through origin. Always it has some value, right? So initially it should have value, and that value keeps on decreasing to decrease the value. So finally the velocity should become 0, which means what? Initially there must be some value. So the velocity time graph can never pass through the origin. And how the graph is going to be, children? Look at here. This is time and here is a velocity. Okay, now. So it has some value as t is equal to 0. So v is going to be u, right? This will be 0. So v is equal to u means it has some initial value, and this will be keeps on decreasing. So here this is slope and it is a negative, right? So it has a negative slope. So from this we can say that means initially it has some slope, children. Try to understand. Here also, if you can see here, it has some value. So this is how actually velocity time graph is going to be. And I repeat once again, velocity time graph cannot be, means can never pass through the origin. Why it can never pass through the origin? Because u cannot be 0 in this case. So always it has some y-intercept. Okay, fine. Have you copied this? Then we see once how the equation for a displacement. Correct? Erase this? Yes. So now third one, displacement time. So S is equal to ut minus of at square. Why S is equal to ut minus half at square? We are going to get, think once. Okay, why we are writing here minus? Why not plus? Because acceleration is a negative. Now in this equation, if you substitute t, of course, what kind of equation is it? It is a quadratic equation, and we are going to get a parabola. Okay, so in this, if you substitute time is equal to 0, then displacement will be 0, which means what? That parabola starts from the origin. Okay, now let us draw the graph, children. So here is time axis. Here is displacement axis. So it is going to start from like this. Wait. Let me draw. So keeps on decreasing. Fine, it will be. Means if you can see, for example, at a point A you can draw a tangent. At a point B you can draw a tangent. So here tangent. This will be theta 1. Let us say that. And here if you can draw a tangent, okay now. theta. So the slope is decreasing. Slope is decreasing and less than 90 degrees. So slope is nothing but the, for a displacement time graph, slope is nothing but the velocity. Less than 90 degrees means what? Actually it is a positive. So velocity decreasing but in a positive direction. And finally, if you can see here at a point C, what is the slope mark? Here slope is 0. Slope is nothing but the velocity. So velocity finally it is 0. So initial if you can see the slope is decreasing at a point C, the slope is 0. That is what actually our discussion is. So it is for a uniformly retarded. This is the third one, sorry, not second one. Uniformly retarded motion. Is the point clear? Fine. Now children, the one very important, of course it doesn't mean that these three are not important, don't think like that. Okay, so the third one is uniformly retarded and accelerated in an opposite direction. Children, can you think any case for this? Meanwhile, I will write the heading. You can think. Opposite in direction. So children, I repeat once again. Initially it is retarded in uniform manner and after some time starts accelerated. So let us take an example where, for suppose here is a body is there. If a body is thrown vertical upwards, children, to throw this body in upward vertical upward direction, should we give some initial velocity or not? Yes. So let us say that here it has some initial velocity. As it is going vertical upward direction, okay na, its velocity keeps on decreasing. Why? Because acceleration due to gravity is a downward direction, but velocity is upward direction, which means what? In upward direction, body is retarded. As it is going vertical upward direction, yes, velocity keeps on decreasing. At a maximum height, velocity will become 0. Then it starts coming back. As it is coming back, children, its a velocity and acceleration both are in the same direction and the body is accelerated. But in which direction body is retarded? Upward direction. In which direction body is accelerated? Downward direction. Upward direction is positive, downward direction is negative. Which means what? In a positive direction body is retarded. In a negative direction body is accelerated. Let us take one case, simple case. So let us study this because studying this situation is very important. So let us say that children, here is body. Is it initially at rest? No. Initially it has some velocity. So let us say this body is thrown vertical upwards. Body is thrown. So body is thrown with some initial velocity. And as velocity, see, I repeat once again, children, velocity direction is upward direction. But still at any instant you can take, acceleration due to gravity will be downward direction. Down. Here velocity is positive. But here acceleration due to gravity is negative. Okay. As it keeps on moving vertical upward direction, yes, as velocity in the acceleration opposite direction, the body is retarded. So the velocity keeps on decreasing. Finally, it becomes 0. Let us see that one situation. Okay. Here velocity will become 0. Then what happens? The body then, okay, the body, same body here, now starts its journey in a backward direction, in a reverse way, that is in an opposite direction. Now in this case, acceleration is downward direction, negative, velocity is downward direction, negative only. Hence body is accelerated. So the body velocity keeps on increasing. But children, let us say this is a point A, point of projection, and this point B, the point where it is hitting the ground. The very important thing is this. Of course, throughout the journey, G is a constant and a negative. Why it is negative? In a upward direction or downward direction or at a maximum height. G value is always negative. Why? Because G value is always downward direction. So as per the sign convention rules, downward direction we can take as a negative. Is the point clear? Fine. And one more thing. So let us say it is a O. Children, A to O, the displacement is increasing. But whereas when it starts again O to B, displacement is decreasing. But finally, what is the displacement, children? So for example, don't see this one. You may get wondered, sir, this place is there. Of course, sir, in a practical case, this one. Actually, my idea is that the body is thrown from here only, again is coming back to the same point. Coming back to the same point. In that case, what is the displacement? Displacement is 0. But distance is not 0. For example, this height is h. h plus h. Distance is 2h. So displacement is 0. Distance is 2h. But how about the sign convention, sign for the velocity? At a point of projection, velocity upward direction. So here, velocity is a positive. But whereas here, children, the velocity is the downward direction, right? At this point, the point where it is hitting the ground, there, velocity is negative. So now first let us study the acceleration time graph. Children, throughout journey, acceleration is constant and negative. Acceleration is a constant and negative. Then we get time acceleration, of course. So we get, this is what actually, this is a graph. So here A is equal to G is equal to minus 9.8 meter per second square. So this is how the acceleration time graph is going to be. Now how about the velocity time graph? Yes. Fine. So children, velocity time graph. See, as initially body is thrown vertical upward direction, is there any chance for a velocity to become 0? No. Velocity is not going to be 0, which means what here? Velocity time graph, of course, it is like a, see, v is equal to what? Upward direction, v is equal to u minus at. But downward direction, v is equal to u plus at. So in upward direction, if you can see, v is equal to u minus at. Children, in this, if you substitute t is equal to 0, v can never be 0, which means what? So whatever the graph which we are going to obtain, it won't start from the rest. It is a linear graph only, straight line only, but won't start from the origin. Okay, so look at here. So children, it's very important to understand this. Very, very important. So it A to O, O to B. Okay, fine. So let us study. Two parts are there in this. Time. Here is velocity, let us say. So initially, of course, velocity is taken in y-axis. So initially, it has some y-intercept. So this will, it has some value u. Okay. Then we get a graph like this. So as A to O, what is happening? Let us say it is point A. It is point A. So at a point A, it has some velocity that keeps on decreasing. At a particular point, let us say O. Velocity is how much? 0. Then after that, velocity keeps on increasing, but in a negative direction it is increasing. Negative direction. Hence, we get a graph. Okay, we get a graph. Get a graph like this. So this is a point. Wait, let me. So you better use a scale pencil, children, here. Okay. This is a point B. This is a point B. So this is how actually velocity time graph is going to be. And here is a velocity is a negative. Here velocity is a positive. So try to understand, children. Here A to O, velocity is decreasing. It becomes 0 at a maximum height. Again further, velocity is increasing, but in a negative direction, velocity is increasing. Negative direction, velocity is increasing. Fine. So velocity time graph, we are getting a straight line. Why? Because it's a linear. As I told you that from A to O, as the velocity is in a positive direction but decreasing. So positive direction but decreasing becomes 0. And again reverse journey, O to B, the velocity is increasing but in a negative direction. So this will be a positive, it will be negative. So this is our acceleration time graph and displacement, velocity time graph. And the last one is displacement time graph. How the displacement time graph is going to be. So children, let us study here. So displacement time graph. So as I told you, there are two parts in this. A to O, one part, O to B, one more part. So A to O, what is happening here? Displacement is increasing. Whereas here, displacement is decreasing. Try to understand. In an upward direction, displacement is increasing. Reverse journey, what is the displacement is decreasing. So finally it has to come back. So it has to be 0 only. Now here let us see S is equal to ut plus, what is that? Ut plus half at square, ut plus half at square only. Okay, fine. Yes. Okay, so definitely as S is equal to ut plus half at square, initially displacement is 0, right? Initially 0 only. So when you put t is equal to 0, S will be 0. Finally also you put t is equal to 0, S is equal to 0 only. So it starts from the origin, again it coincides with the x-axis only, no doubt about it. But as I told you, A to O it is increasing, O to B it is decreasing. And in the quadratic equation we are going to get a parabola. So for this children, if you can see, the displacement time graph is a parabola starting from the origin. Let us say it's a point A. From here we are thinking. So A to O, yes, it is increasing exponentially, yes. And here let us say this is a point where it is O. At O displacement is maximum, then O to B it is decreasing. So this is how actually velocity direction towards negative finally. So velocity direction is here is a negative. Of course you can find here, if you can find the slope, this slope is a theta 1, yes, it is less than 9 degrees positive. Whereas here if you can find the slope children, this theta 2, it is greater than 90 degrees, so it is a negative. So at a point of projection velocity is positive, whereas here it is negative. But at this point if you can see the slope, yes, this slope is going to be 0. Slope is nothing but the velocity. So children, these are the graphs related to the kinematics. Children, graphs means, my suggestion is that don't study ST graphs, VT graphs and AT graphs. It's not that. First, what is our intention? To study the one-dimensional motion. So in a one-dimensional motion, we have 4 categories, 4 types: uniform motion, uniformly accelerated motion, uniformly retarded motion, uniformly retarded, and then uniformly accelerated motion. Here we have 4 types of motion. In each and every type of motion, how acceleration time graph, velocity time graph, displacement time graph are going to take a shape is very important. So if you want to know that, as I told you that first we should study the equation between the between 2 physical quantities. The equation between the 2 quantities will decide the shape of the graph. And already I told you that whether that particular graph passes through the origin or not. How to decide, children? Yes, when you put x is equal to 0, if y is equal to 0, then passes through the origin. If not, it won't pass through the origin. So dear children, so these are the complete, this is the complete discussion about the graphs from the kinematics. Okay children, thank you so much. All the very best.